Okay, so here's some notes I do for my high schoolers, and I think you'll find them just as useful here. When you talk on a sequence is a set of numbers that it follows some rule, and there's more than these two, but these are the two common ones, and you'll see others. If you go into Calc 3, maybe the end of Calc 2, you'll see some other kind of sequences of series. And then there's like the Fibonacci sequence, but we won't go there. So either a recursive formula you can create, which means you're given some first term, some starting point, and then you follow some rule to get the next number. So a sub 1 is the first term. To get the next number, so the next number, or the next term we'll call it, you take the last term, that's where the n, so the nth term, we take the n minus 1 term, which is the last term we have, not the last term in the sequence, but the last term that we have. Or maybe I should call this previous term. Let me change it to that. That'll be better. So the previous term, and then whatever, this is called the common difference when it's arithmetic, because we're either adding the same number or subtracting the same number. So D is called the common difference. Okay, and then we can have the explicit form, which says to find the next term, we take the first term. So for example, suppose I want to know the 10th term. Let's do this. Let me actually let's do one. So suppose I've got the first term is 10, and then they want me to add 5 each time. So I'm going to go take the last term. We'll write a sub n minus 1. I could write the last term. Plus 5. I don't remember what I just said, but we're going to make it plus 5. So if I wanted to find, say, the 8th term, I'd have to go with 10 and get 15, and then get 20, and then 25, and then 30, and 35, and 40, and then 45. So that would be the 8th term. So a sub 8 would be 45. Now, what if we wanted to get the 8th term without doing all that work? So the explicit formula is what lets us do that. So the explicit formula is always in the form a sub n equals your first term, which in this case 10, plus your common difference, which I said was 5, times n minus 1. So if I wanted to find the 8th term, a sub 8, I'd go 10 plus 5 times 7, because n minus 1, 8 minus 1 is 7, which is going to be 35. 35 plus 10 is 45. So explicit form is much more useful, but there are places where the recursive form really works. I mean, the little bit of programming I've done, I know they use a lot of recursive thinking in that, because computers can do this very quickly, right? So then I added this because in chapter 2, section 2, the chapter 1, 2, and 3, we talk about linear functions. If I took my a sub n equals 10 plus 5 times n minus 1, and then I put it in this formula, this form, I'd have to distribute the 5 through. So 10 plus 5n minus 5, so that would give me 5n plus 5, because 10 minus 5. So that is this form. So a sub 0, so let's just put this, a sub 0 is the y-intercept. That's the 0 term. And then the common difference is the same thing as the slope. So it's the same thing. You'll see it both ways. I honestly believe that this is the better way to write an explicit form, because you can see how it follows with a sequence. But an arithmetic sequence is just a linear function, so you can certainly think about it that way too. Okay, so that is a recursive form for an arithmetic sequence, an explicit form for an arithmetic sequence. Then we get into series. So let me do some erasing here. And come on. Can I erase this? Oh, just a minute here. Let me, I don't want to get rid of the original. There we go. That's done with most of it. So with an arithmetic sequence, it's kind of cool. You take the first term plus the last term, and then you add them together, and then you take the number of terms divided by 2. So like, let's go back to that example I just had. I had 10, 10, 15, 20, 25, 30, 35, 40, 45. If I wanted to find the sum of the first 8 terms in that sequence, I could add up 10 plus 15 plus 20 plus 25 plus 30 plus 35 plus 40 plus 45. I don't know why I wrote 48 there. Okay, so and we could do it that way. For 8 numbers, that's not unreasonable. But I mean, if you're talking about 800 numbers, well, then that's a pain in the butt. So what you do is you take the first term, which is 10. We take our 45, which is the last term. And then because these are 8 terms, I'm going to do 8 divided by 2. So 55 times 4 will be what? 220. So 220, if I'm doing my arithmetic right. That's the sum of those 8 numbers, and you can do that yourself if you want to verify it. But that's how it works. What if they wanted to find? What if I said, let's find the sum of the first 800 terms? I honestly do that on a quiz because I don't want people just to add up the 8 numbers. High school students always do that. They want to learn the new way. So suppose I want to find the sum of the first 800 numbers in this sequence. 800. So I could do the first term, which is 10. Then I'd have to find the last term. And we have that explicit formula. What was it? It was 8 to find. So if I want to find the 800th term, I would take 10 plus 5 times 800 minus 1. And I am going to grab a calculator for this. 10 plus 5 times 799. Well, maybe I can do this in my head. Let's see. If it was 800, it would be 40 with 2 zeros. I'm taking away 5, so that'll be 300,995. Okay, so that's going to be the what the n minus 1 is, and then we're going to add 10, so that would be 4,005, right? So if I'm doing that arithmetic correctly, the 800th term is 4,005. So let's go find that series now. Let's go find the sum of those 400 terms. Whoops, the LMA. Can I delete this without deleting everything? Yes. All right, so I'm going to do first term of 10 plus the 800th term, which I believe is that, over 800 divided by 2. So that's going to be 4,015 times 400. And I'm not going to finish it. Grab a calculator and do it. Okay. So that's how you can do it, and that's why this explicit form is useful if you're trying to find it. Real life, where is that? Anything that's a linear model, we could do this if you wanted to. Okay. So that's arithmetic sequences. A recursive form, explicit form, then the arithmetic series. Let's go take a look at. So we're going to take a look at some practice problems now. Okay, so there I wrote down I want to write a recursive form for this sequence defined by the first term of 18 with a common difference of 7. Then I'm supposed to write the next 4 terms. Okay, so I mean, if you want, you can stop it and try it yourself, or I'm just going to go ahead and do that. So the recursive formula will be a sub 1 equals 18, and then a sub n equals a sub n minus 1 plus 7, and that's all you have to do. And then to get the next 4 terms, or the first 4 terms, well, we already know the first term is 18, so the next term will be a sub 2 will be add 7 to that, which is 25. A sub 3 would be add 7 to that, which is 34. A sub 4 will add 7 to that, which is 41. Okay, that easy. Okay, why don't you try the next one? So what I'm going to do is delete this stuff. Let's see. Delete. Let me delete it. Come on, I want to delete it. Come on. Delete. Let me select it. Oh, let me select it. I should have just stopped the video. Sorry about that. So here's the next one. It's a recursive formula. A sub 1 equals -7. a sub n equals a sub n minus 1 minus 3. So then we're going to get negative 10, we're going to get negative 13, negative 16, negative 19. Okay. So we're supposed to do the explicit form for these. So ask yourself, what's the first term, what's the common difference, and go from there. And I'll just do this now. So I see it's going up by 4 each time. So a sub n equals 11 plus 4 times n minus 1 would be a recursive formula. Then, I mean the explicit formula. They want us to find the 21st term. So a sub 21 equals 11 plus 4 times 20, because it's n minus 1. So that's going to be what? 80 plus 11 is 91. While I'm at this, what would the series be? What if I wanted to find the sum of the first 21 terms? I guess I didn't throw that on this. I mean, I'm going to do it right now, so you can stop and try it yourself, or just follow along. So first term is 11. We know our 21st term is 91. So 11 plus 91 over 21 times 21 over 2. So that's going to be 102. 102, Dan, not 110. 102. And then times, what is that, 11 and a half? Or 10 and a half, 10.5. And again, you can do a calculator, you can do a number of ways. You can multiply those two. Okay, then for this next one, you can stop it if you want. I'll continue. I see that I'm subtracting 0.3 each time. So the explicit formula is a sub n equals 8.6 minus, or plus. I mean, I guess you could write it plus or minus if you wanted to. And 3 again, not 2, times n minus 1. And then to find the 31st term, so a sub 31 would equal 8.6 minus 0.3 times 30. Won't that be 9? So 8.6 minus 9 is negative 0.4. Yeah, negative point. So that's the 31st term. And if we want to find the sum of this series, we'd take the 8.6. I'm running out of space. Oh, maybe I'm not running out of space. This is a expandable board. So 8.6 plus negative 0.4, first term, last term, times 31 over 2. And so that would be what? 8.2 times 15.5. And we could do that. And we could do it with fractions if you wanted to. Okay, so hopefully this helps. Hopefully this gives you a flavor of what an arithmetic sequence is. Before the first exam, we'll look at exponential functions and geometric sequences also. Alrighty, hope this helps. Hope the audio came through better in this one.